Hello everyone, I'm Frank, and welcome to Frank Puzzles. And this is today's easy level puzzle. And take that easiness with a grain of salt, because it's considered easy by the people on the Logic Masters Germany forum. And there's a lot of really smart people there. Today's puzzle is called Hidden Paths by Macetab. And here are the rules. We have normal Sudoku rules applied, which means place the digits 1 through 9 such that each appears exactly once in every row, column, and 3x3 box. We have dynamic fog, where the grid begins covered in fog. Placing correct digits will lift the fog from that cell and may also reveal additional cells or clues elsewhere. I like this actually, this type of dynamic fog, because it gives you a nice little dopamine hit every time you see something clear out. So that's nice. We have German whispers, where adjacent digits on green lines must differ by at least 5. And I like to call them whisper 5 lines. It was not something that I invented. A setter actually created it, and I think it just made a lot of sense to call them whisper 5 lines. But, you know, people can call them German whisper or whisper 5 lines, and it is what it is. We also, so for example, on the whisper 5 lines, if you have a 3 here, this would have to be an 8 or a 9, because the only digits which are 5 or more away from 3 are 8 and 9, which is why they have to be there for this digit if this were a 3. And that's an example of how German whispers or whisper 5 lines work. We have Renban lines, where digits on purple lines must form a consecutive set in any order. So, for example, you could have something like, say, 3, 5, and 4 here. And this would be valid because 3, 4, and 5 form a set of consecutive digits. What you could not have is something like, say, 7, 5, 4, because 4, 5, 7 does not form a set of consecutive digits. And those are examples of how Renban lines work and don't work. Oh, whoops, I shouldn't be using full numbers here, because that might actually solve some things. Probably it doesn't, but it does. Like, better to be safe than sorry. We have palindromes, where digits on gray lines must read the same forwards and backwards. That means this line must read the same going this way as it does going this way. That should lead to some, I'm not going to say obvious, but some, you should have some intuitions based off of that. I guess I'll put it that way. We have arrows, where digits along an arrow must sum to the digit in its connected circle. So all 5 of these digits must sum up to what that digit is. We won't go into detail about that. That would start solving things. And we should have killer cages in this puzzle, where digits inside a dash cage must sum to the value shown in the upper left corner of the cage. So say we had a cage here, and say the digit in the corner was, say, 9. Then we could have something like 4 and 5 here, and that would sum up to 9, which is the value of the digits, the sum of the digits in the cage. And that's an example of how killer cages work. And finally, we have Kropke dots, where a black dot indicates 2 digits are in a 1-to-2 ratio, and a white dot indicates that the digits are consecutive, and not all possible dots are given. So, as an example, say we have the black X marks a black dot, and the blue X marks a white dot. So, if this were, say, a 4, this would have to be a 2 or an 8 to maintain the 1-to-2 ratio between them. And if, say, this were 3, this would have to be 2 or 4 to make sure that these digits are consecutive with each other. So this again is assuming there was a black dot here and there's a white dot here, and this was 4 and 3, right? And those are all the rules. If you like to play along, there's going to be a link in the description. And now, I'm going to get started. Let's go. Okay, so the arrow here, these 3 digits are in the same box, so it's minimum 1, 2, 3. These digits are in the same box, it's 1 and 2 at minimum. Well, what does that minimum add up to? It adds up to 9, because 1, 2, 3 add up to 6, 1, 2 add up to 3, 6 plus 3 is 9. So this is 9. This is a 1, 2 pair. Oh, I could have actually. It showed that. Interesting. So this is 1, 2, and 3. These 2 digits add up to 16. It must be a 7, 9 pair. Where can 9 be in box 1? Cannot be here, cannot be here. Can't be here because this is a palindrome. So not here, not here, not here. If 9 were here, it would have to have 7 and 8 be on its Renban with it. But 7 can't be here, and if 9 is here, this can't form then a 7, 8, 9 Renban. So 9 cannot be here or here. 9 has to be on the Renban here. So this must be a 7, 8, 9 triplet here. We also know 5 has to be on this palindrome here, because 5 can never be on a Whisper 5 line. And the reason why is subtract 5 or more from 5. What digit do you get? You get 0 or less, which is not a normal Sudoku digit. And if you add 5 or more to 5, you get 10 or more, which are not digits. So 5 has to be one of these 3, which means 5 is one of these 3. So this must be 2, 3, 4, or 1, 2, 3 in the remaining Renban. Because we cannot have 5 on this Renban because it must be on the palindrome. So if it's 1, 2, 3 here, the problem is we'd have 4 cells in column 3, which would require 1, 2, and 3, which is not possible because, again, you have 4 cells requiring 3 digits. So one of them would be left empty. Then that doesn't work. So this must be 2, 3, 4, which means the remaining digits on the palindrome are 1, 5, and 6. So this palindrome then is also 1, 5, or 6. There must be a 4 somewhere here in box on a Whisper 5 line. And that 4 has to be next to a 9. Well, 9 cannot be here. 4 cannot be next to 2 unique digits on a Whisper 5 line. So 4 can't be here. 4 can't be here because that would force 9 to be there, and we already have a 9 in the column. And so 4 can't be here. So 4 has to be one of these 2, which means the 9 has to be here. So this is 9. And 4 can be with 2 or 3. The remaining digits in box 5 that are not on the palindrome are 7 and 8. What digit can they be next to if it's not 1? It has to be 2. So this is 2 next to 7 or 8. And this must be 9 next to 3 or 4. We have a 1, 2, 3, 4 quadruplet in column 3, which eliminates 1, 2, 3, 4 in the rest of the column. So this can't be 1. This is 5, 6, or 8. 5, not 5 there. 5, 6, or 8 there. So since this is 5, 6, this must be 5, 6. 1 has to be one of these 2, so this can't be 1 here. 4 is one of these 2, so this can't be 4 here. No 2 here because of 2 in the row. This is a 1 to 2 ratio, and it cannot have 1 and 2. So it's either 3, 6 or 4, 8. We're not sure which. This has to have a low digit and a high digit here. We already have a 1, 2 pair in row 3, so this can't be 1 or 2 as a low. So it must be either 3 or 4 as the low, which means it has to be with 8 or 9 as the high. Well, we know 9 has to be one of these two digits, so this can't be 9. Therefore, the high here has to be 8 with 3. So that eliminates 8 in the rest of the row and 3 in the rest of the box. So this cannot be a 3-6 pair in a 1 to 2 ratio. It cannot be 4 and 8. So this can't be 1 or 2. Can't be 3 or 8. This has to be 4 then. So this is 4 with 2 in a 1 to 2 ratio. That leaves this digit as 5 and 6. The 7-9 pair eliminates 7 in the rest of the box, so this is 8. This cannot be 8 here, so therefore this can't be 4. This 2 eliminates 2 here. Okay. Interesting. What else do we have? Nine has to be one of those 3. 7, 9 as a pair. This is 8. Hmm. Remaining digits of box 3. We have 1, 5, 6, 7, 9. Obviously no 9 there. What are the remaining digits of column 4? No 9. We cannot have 3 or 4 because one of these is 3 or 4 and this is 3 or 4. That means we could have 1, 2, 5, 6, 7, or 8. And we know the 7 has to be one of these 3 because it cannot be anywhere else in column 4. Remaining digits in box 2 are 3, 4, 5, 6, 7, 8. Obviously no 8 here. Remaining digits in box 4 are 4 through 9. No 8 here, no 9 here. Hmm. 9 has to be in one of these cells here. These are the same digit. Okay, so let's mark these. I don't know. These could be pink, I guess. We'll make this blue and this red. This is the other one. Oh, wait. Okay. There we go. So this digit cannot be blue and it cannot be red. Therefore, it must be the same as pink. So this has to be a 5-6 pair, which means this is 5 and 6, which means this is 1 and this is 1. So this is 1 and this is 1. This must be pink here. So this can never have a 6, because if this were 6, it sees the red version and it sees the pink also of 5 and 6. So this has to be 4 and 8. So this is 4, this is 8. That means this can't be 4, that's 3, which this means this can't be 3, that's 2, this can't be 2 or 3, that's 4, which means this can't be 3, that's 1, this can't be 1 or 3, that's 2. That can't be 2, so that's 3. Oh, that's not that satisfying. Anyways, this 3 eliminates 3 here, so it's 4 and 3. I don't really like that, actually, thinking about it, but anyways, it is what it is. This can't be 3 or 4. No 4 or 8, no 4 or 8. So 1 cannot be any of these cells. These digits are consecutive, therefore it cannot be 1 here or 9 here, because it doesn't have a 2 to be consecutive with or an 8 to be consecutive with. So this must have a 6 to be consecutive with 5 or 7. 1 has to be here. 9 is one of these two, and this cannot be 6 here. So 9 is here. 3 is one of these two. 4 eliminates 4 here. This one of these is the pink 5, 6. We're not sure which one. One in box 4, sorry, 6 has to be one of these two. Because it cannot be here, cannot be here, cannot be here. One in box 7 has to be one of those 3. This can't be 8. So the pink 5, 6 has to be one of these 3. We have also a 1, 2. One of the 1 or 2s is there. Let's go here. 5 cannot be on, as I said, the Whisper 5 line. But what could it be? We have a guaranteed 5 on a Renban, but that doesn't tell us too much. What are the possible digits on the Whisper 5 line? We have 1, 3. Oops, not colors. 1, 3 as lows. 6, 7, 8, 9 as highs. You can't have 6 here. If this were 6, that would force a 1 here, which is impossible because of 1 in the column. So 1 or 3 could be with 7, 8, or 9 here, or 2 or 3 here. Oh, wait, but these form Renbands, don't they? Okay. So say you had a 3 in the middle. If you had a 3 in the middle, that would mean 8 and 9 are on the outside here, on next to the Whisper 5 line. And that's not possible, because then you'd have 1 and 2 on a 3-length Renban without a 3 possible. So this cannot be 3. If you had 2 here, you have the same problem. If you have 2 here, you have 7, 8, 9 on the outside, but then you have 1 on a Renban without a 2 possible in its set. So this cannot be 2. This is 7, 8, 9, which is next to 1 or 3, or 1, 2, 3, or 4. And if you have the same problem with 7 and 8 here, right? If you have 7, that means these digits are not 8 and 9. You have 8 and 9 on a Renban without a 7 possible for a 3-length Renban. Same with 8. So this has to be 9. So this is 9. It has to have a 1 with it, and then also a 2. Because otherwise you can't form 3-length Renbans in these sets. So this has to be 1, which makes this 2. So 1 cannot be here. This is 1 there. We have 3, 4, 5, 6, 7, 8 for the Renban. We don't know which is which. This, we know this can't be 4 and this can't be 6 because of the 4 in the column and the 6 in the column. This 9 eliminates 9 here. So therefore, this is a 9 here. 9 can't be here, here, or here in box 6. It must be here. That eliminates 9 from the rest of row 4. Okay. We have to have a 2 remaining in row 6. And it cannot be here because of 2's in the boxes. Can't be here or here because 2's in a row, or 2's in the column, so it must be here. That leaves us 5, 6, 7, 8 remaining in row 6. 4 has to be one of these 3 digits. One can't be here. 1 can't be here. 2 can't be here because of 2 in the row. So 1 is one of those 2. 1 is one of these 4. 9 eliminates 9 here, so it's 7, which makes this 9. So this cannot be 7 here. 9 cannot be either of these 2 digits, so where's 9 in column 5? It has to be here. This can't be 7. This can't be 7. Okay, we should have... Yeah, we only have 7 9s, so unfortunately we don't have enough information. How do these Renbans work? 6, 7, 8, and 3, 4, and 5 are together. So if this is 6, 7, 8... 6 cannot be here because of 6 in the column. This can't be 7, so this would be the 8, which means 8 cannot appear elsewhere in this Renban. This can't be 7, so you would have to have 6, 7, and 8 there. Okay. Where is 4 in column 9? Can't be any of these cells. This can't, because there's the 4 in the box. These are set, and this can't be 4 because of 4 in the row. This is set, so 4 has to be one of these 2, which means this is a 3, 4, 5 triplet here. So this is 3, 4, 5, which eliminates 3, 4, and 5 in the rest of the box. So this is 6, 7, 8 here. 4 has to be one of these 2, so this cannot be 4 here. 6, 7, 8. Where is 3 in column 7? Cannot be here anymore because of the Renban. 3, 4, 5 has to be there. Can't be here because of 3's in the row, so 3 has to be here. This is also a Renban, so 9 cannot appear on it because we can't have an 8 available on it. So where is 9 in row 5? It has to be here now, which means we know this can't be 9. This is 7, which makes that 9. So 7 cannot appear here. 7 can't also appear here because of 7's in the columns. So 7 must be on the Ren band. So it's 5, 6, and 7 as the Ren band. That eliminates 5 and 6 in the rest of the row or the box. So this can't be 5 or 6. This is 8. This can't be 4, 5, 6, or 8. It's 4. This 8 eliminates 8 in the rest of the row and column. So this is the pink 5, 6, which means this cannot be pink 5, 6. So this is not 5 or 6 here. Because it can't be pink 5, 6, can't be red 5, 6, so neither 5, 6 can be there. Remaining digits in column 1 are 2, 3, and 4. And this can't be 2 because of 2 in the row. Remaining digits of column 2 are 1, 5, 6, and 8. And this can't be 1. Okay. What else do we have? We are missing a 4 in row 5. Cannot be here because 4 is in the boxes. Can't be here because 4 in the column. Can't be here because that's set, so this must be 4 here. We have 5, 6, 7, 8 remaining in box 6. Where's 5 in column 7? Cannot be here because this is a 6, 7, 8 triplet. Actually, 7 has to be here, so this can't be 7 here, which means we know where the 7 is in column 4. It has to be here. Or yeah, this is 7. 5 in column 7 has to be one of these two because it can't be here because it can't be part of the 6, 7, 8 triplet, which it has to be. So 5 has to be one of these two, which eliminates 5 from the rest of the box. Oh, we have a 5, 6, 7 triplet in column 9, which eliminates 5, 6, and 7 in the rest of the column. This can't be 5. This can't be 6 because one of these must be 6 to be consecutive, so this is 7. This 3, 4 pair eliminates 3 and 4 in the rest of the column, so this is not 3, that's 8, which makes this 3. This 7, okay, this 3, 4 pair also eliminates 3 here, so that's 5, which eliminates 5 here. So all the pink 5, 6s are all 6. And all the red 5, 6s are all 5. So there's no 6s here. This can't be 6 because of 6 in the row. So 6 has to be here. So this is 6. No 6 here. No 7 here. No 7 here. No 7 here. No 7 here. We have a 5. This 7 eliminates 7 here, so this is 5, which makes this 7. This 5 eliminates 5 here, so it's 7, which eliminates 7 here. This becomes a 3, 5 pair. 7 here eliminates 7 here, so where's the 7 in box 9? It has to be here. So this is 7. This 7 eliminates 7 here, so it's 8, which makes this 7. 8 eliminates 8 here, so it's 6, which makes this not 6, so it's 5 and 8. 5 eliminates 5 here, this can't be 6. Sorry, it has to be 6. This can't be 6 or 7, it's 5. It can't be 5 or 6, it's 7. This 5 eliminates 5 here, and it cannot be 6, so this is 8. We then have a 1, 5 pair here. Neither of these can be 5 because of 5 in the column. Remaining digits in row 7. This has to be 2, 3, or 4. It cannot be 2, so this is 3 or 4. We have a 3, 4 pair in row 7, which eliminates 3 and 4 in the rest of the row. So this must not be 3 or 4. It's 2. No 2 here. Okay. This 8 eliminates 8 here, so this can't be 8. It's 6, which means this can't be 6. That's 8. So there's no 6 here. We have a 1, 2 pair in column 4, which eliminates 1 and 2 in the rest of the column, so this can't be 1 or 2. It's 6. Okay, maybe we can start coloring the 1s and 2s then. We're going to make this red and then yellow. So this is the yellow 1, 2. The red 1, 2 has to be one of these two. That's not helpful. Remaining digits in column 5. 1, 2, 3, and 5. Remaining digits in column 6. Well, we have to have an 8. And 8 cannot be here, here, or here, so it has to be here. So this is 8 with 3, 4, or 5. These two digits are consecutive, so it cannot have a 5 here. So we know one of these is 3. It has to be consecutive with 2. That means we can eliminate 2 in the yellow digits, so these are both 1. Red is 2. This 2 eliminates 2 here, so this is 3, that's 2. 3 eliminates 3 here, so it's 5 and 3, which eliminates 3 here, so it's 4 and 5. 5 eliminates 5 here, so it's 1 and 5. 3 eliminates 3 here, so it's 4 and 3, which eliminates 3 here, so it's 4 and 3. And that's the solution. Yeah, I'm not sure how I feel about it. Though I mean, it's hard to say. Sometimes I feel like you don't get enough dopamine hits out of the dynamic fog of war, and I kind of felt that way here. I don't know if it's just probably personal preference here. I mean, it was well constructed. There was a lot of nice logic here. I don't know. I just didn't get enough dopamine hits, I guess. Anyways, I hope you enjoyed this solve, and I'll see you next time on Frank Puzzles. Take care.